11.8 seconds. Across the internet, 11.8 seconds is the average amount of time it takes for a page to load. As our browsers and computers and the network has gotten faster, we've taken the opportunity to shove more and more data over the pipe to the user. And the end result, the user's experience has not gotten any faster, and the user is still waiting around for web pages to load. You'll walk out of here at the end of the talk having seen the 3 keys to creating an engaging experience that will keep people far more engaged for far longer. These 3 keys are applicable to any single-page web application development framework that you choose to use, and will be applicable to ones that are developed in the future. When you click on a button on a website, if there's a reaction within 0.1 seconds, you'll come to consider that reaction to have happened immediately. That it is an exact result of your interacting with the website and taking that action. You might even begin to experience the website as an extension of yourself and come to love its fast, quick, interactive experience. If, after pushing a button, it takes a second for the website to reload, you'll begin to notice a lag. You'll separate yourself from the experience, and the experience won't feel snappy, quick, or as interactive. If it takes up to 10 seconds for the reaction to occur, you'll start thinking about something else. You'll start thinking about, should I check my email? What do I want to have for lunch? Should I go surf another website? And if that action takes longer than 10 seconds, you will leave. You won't wait around for it to finish. And then you'll end up trying to come back later and see if that action finished. Quite often when this happens, it's the result of a error happening, but not passing that error on to the user, and the user seeing a spinning icon continue to happen. And I've had users of my web applications come back hours later saying the website's still loading, even though the spinning icon, because the spinning icon is still spinning. So what does it mean that the average web page takes 11.8 seconds to load when you've got 1 second to create an interactive experience and 10 seconds before you lose your user's attention at all? The first key to developing an engaging experience that will keep your users far more engaged for far longer is to move your logic and data from the server to the client. And to understand why this is important, we'll have to take a look at the traditional model of a web application. This would be your standard Ruby on Rails, Python, Django, or any other MVC server-side application. And in fact, is the way that the internet has worked for most of its history. The browser makes a request to the server responds with some HTML. The HTML contains requests for CSS, images, JavaScript, Flash, video, and whatever. And so the browser will then request all these things from the server, and the server will respond with them. This can now takes up to an average of about 100 different requests per web page across the internet. And every time you click on a link or move to another page, it happens all over again. Yes, there'll be some caching that gets in the way, so not all the requests are made or all the requests have to fully process, but you still have this many amounts of round trips going back and forth to the server and trying to get information to load into the page. So the first bottleneck in this strategy is the network latency from the first request from the client going to the server. Considering you've only got 100 milliseconds in order to respond, in order to have this fast, fun, snappy application, the network latency can eat up all that time by itself. Then the server has to process the request and figure out what to do with it. Often this is very quick, but that request might have to query the database. In data-intensive applications, this can take an awful long time and eat up the rest of your 10 seconds. but in many applications, this also happens very quickly. Then the server has to process the results of this query, often generating HTML strings, which are then sent back across the network, experience the network latency again, and finally, the client renders the page. So rather than go through this long process every time the user requests a page or wants to see some new information, by moving your logic and data to the client, you can just immediately use that information and render it, bypassing the server, the database, the server-side database, and the network latency altogether. This has the additional benefit of creating a byproduct of creating as a byproduct distributed computing, where all of this HTML string concatenation that was being processed on the server is pushed off onto the connected clients. So instead of having to build and maintain all of the server hardware to generate these strings and push them back, the people who are connecting to your system are now responsible for maintaining and building the hardware that is going to run your website. So it ends up being a much more scalable and cheaper solution to building a web application. But it turns out that only about 20% of the time spent loading a page is due to the time on the server. And in fact, most of the time, the great bulk of it is done on the client, taking the HTML and generating the page from it. Done some thinking about, why is this? Why is the server so much faster? And I think it's because organizations are built in order to conquer the problem of the back end. The back end's been such a big problem for so long that it's not uncommon in a 100-person engineering organization for only 1 or 2 front-end engineers to be there, where you have 98 concentrating on the problem of the back end. As a result, the back end has been optimized as much as possible, and now all the complications have been solved. It's up to the front-end engineers in the front end to solve more problems. Plus, we're compounding the front end by pushing a lot of things off of the server and onto the client. Which brings us to the second key to creating an engaging experience that will keep people far more engaged for far longer, and that is to load only the changes in the client that happen. So if you picture a standard slideshow that one of your friends has sent you from their wedding, and you get not just the slideshow on the page with the thumbnails of the image, but you also get all the ornamentation around it. That includes the top navigation, the left navigation, ads, footers and text below there. And when you go and you click on a thumbnail, when all you want to see is the picture refresh to the new picture, you end up with a flashing white screen followed by a very slow page load as the entire thing reloads. So contrast that experience with the single page web application, where the only thing that reloads is the image on the page itself when you click on the thumbnail. Now you're not reloading all that HTML off the client that takes up all the different parts of the application. So there's a lot less data being pushed back over the client because you're not reloading the same data over and over again. And you have that snappy 0.1 second user interaction time that keeps users engaged with your application. So the third key to keeping users engaged and around for much longer is to plan for some of the challenges that come with the structural changes involved in pushing code from the server to the client. Rather than focus just on the technical aspects of this, which a lot of talks have, and there's a lot of frameworks out there solving some of the technical problems, I want to focus on things that are going to come up and maybe not as technical in nature. But there are 4 challenges that you're going to encounter. The first challenge being the broken back button. The second, that search engine optimization complications. The third being missing analytics. And the fourth, a lack of error tracking. These are all reasons I've heard from managers not wanting to build a single-page application and saying, no, we're going to stick with the MVC approach, because how do you solve all of these problems? Well, with single-page application, all of these problems are, in fact, solvable. With the broken back button, so imagine, if you will, back to the slideshow presentation. And now they've upgraded it to be a single-page application. And when you go and click on the thumbnails, you go to the next page and to the next page. Well, when somebody presses when you want to go back to the second image, chances are you're not going to click on the second thumbnail because you're using the web and you're used to this interface. You're going to click on the back button. So the back button you would expect to bring you back to number 2. But the problem is that the back button doesn't manage the state of the application. The back button just manages the history of the URL. So when you click the back button, you actually go back to whatever site you were on before you went to the slideshow. And this results in a very jarring user experience, as you're no longer going to be looking at the slideshow and might not even be on the same site and have to figure out how to get back to where you were before. More experienced users of the web will just push the forward button, but other people will have to go back to the email, find the link again, and click on it. So the solution to this problem is to make the URL your API. To drive all changes on your UI and interaction through URL changes, and in doing so, tap into the URL management system of the browsers. By clicking on the back button, you'll cycle back through the URLs, and the site will update. So let's take a look at what this looks like. When a user comes and clicks on the button on a traditional application, you'll then just execute some JavaScript, and a dialog pops up. But rather than having JavaScript execute immediately and pop up the dialog, have clicking the back button update the URL, and then have the URL change initiate the pop-up. So click on the button, update the URL, pop up the dialog. So the code to do this is actually surprisingly simple. All you do is bind a hash change event handler on the window object. And then this event handler function will get executed every time the hash changes. You investigate, OK, what is the value of the hash at this time? Compare it against whatever strings comparison you want to. In this case, we look at does pop-up equal to true. If it is, we pop up the dialog. Else, we hide it again. So what you end up getting here is a very rudimentary router. It's a method of moving your router from your server side to your client side. And you can do, obviously you want to do a lot more complicated interactions with it than just this, but this is the basic thought and format behind it. So let's take a look at what that looks like in an application. So you notice here, this application URL just has index.html on it. Now when I go and click on the Open Dialog button, it updates the URL, and this URL state change pops up the dialog. Then I go and click on the Close button. It updates the URL, removing the pop-up equals true from the hash, and that closes the dialog. Now you open it and close it again. And because you've been activating the pop-up based off of the URL changes, the pop-up's activation is now hooked into the history management system of the browser. So you can click on the back button, and the dialog pops up. Click it again, and it goes away. You're able to copy and paste to another tab, and that wasn't there because it wasn't there before. So we copy and paste to another tab, and the dialog appears. So now you've got control over your web application so that users can take it and send it to friends, put it on Facebook or wherever, and they'll get back to the exact same state in the application as they were when it was sent. Without this, all they would be able to copy is the URL, and it would always just show the open dialog. It wouldn't show up the pop-up they had come to expect. The second challenge involved in building an experience that users will find more engaging and for longer is search engine optimization complications. And to understand why search engine optimization is a problem for single-page applications, you have to understand how search engines index the websites. So search engines index websites through use of a process on their servers called a web crawler that will just go out and visit URLs. It will pull down all the HTML that the server sends back, parse it looking for links, and then it'll go visit those links. And when visiting those links, it'll parse the HTML, look for links, and then it'll go and visit those links. And so in doing so, it'll spider its way, crawl its way throughout your website, indexing the entire thing. But what it doesn't do is it doesn't execute any JavaScript when it goes and visits these web pages. So when it goes and it attempts to visit a hashtag on the end of your URL, it doesn't initiate any JavaScript, your page doesn't update, no new links are presented, and it doesn't go anywhere. Fortunately, even though single-page web applications are a fairly new development, the systems underlying them, namely Ajax, have been around for a while, so that the search engines have come up with a way to allow Ajax to be indexed. And namely, that's through a URL remapping, where it takes it looks for URLs that have a hash bang, so they have the exclamation point after the hashtag. And rather than going and visiting those URLs directly, it remaps it to !_escape fragment _equals. And it goes and it requests that page from your servers. So if you develop your servers so that they respond to this pattern, they will now be able to be indexed by the web crawlers and search engines. And it actually gives your single-page web application an unfair advantage because you're able to segment your responses according to your audience. When you know it's a web crawler coming through to the escape fragment, you can provide very SEO-optimized text and only display the image you want to appear in the search results. And when a person comes in looking at it, you can ignore all search engine optimization practices, and you can focus your text and content directly on the audience who's coming. So now you've got your content optimized to whoever's visiting the site, rather than having to have this conglomerate that's served up to both users. So the third challenge in creating an experience that's far more engaging and will keep your users around for far longer is missing analytics. In your standard traditional MVC application, the analytics code snippet just gets copied and pasted to the bottom of every page. And when the user goes and clicks on a new page, then that's fine. The analytics code is copied and pasted at the bottom of that page too, and the analytics stuff gets activated. On a single-page web application, on the other hand, it's fine on the first request. You can put the snippet in at the bottom of the page, but subsequent requests, they don't request a new page. They request data from the server, and they get JSON strings back. So if you're getting JSON strings back, you don't have this snippet at the bottom of the page. What do you do to track analytics? Well, there's a few ways you could do it. You could just put that HTML snippet in the JSON and program the JavaScript to stick it at the bottom of the page, but that's really going to be an ugly hack. A much better way is to tap into this rudimentary router that we created that executes when the URL gets updated. So when the URL updates, instead of just popping up that dialog, you pop up that dialog and fire an analytics call back to the analytics engine, telling which user updated the dialog when. And so you're actually able to get much finer-grained, detailed analytics because you can track every single user interaction. You can tell what people clicked on by having the URL be differently. You can even make a generic one where you just grab the URL off from the user and send it to the analytics engine, and now you're tracking every single URL change on your application. So getting analytics done for your single-page web application is almost just as simple as doing it for a traditional application. So the fourth and last challenge with developing a single-page web application is the lack of error tracking. In a traditional MVC application, most of the code resides on the server, and so most of your bugs and errors happen on the server. So as a user comes along and encounters an error, then the error is actually generated on the server side. The server just logs it to a file and moves on. And anytime you want to go and find out about those errors, you just go open the log file and look at them, and hey, there's all your errors. But on a single-page application, almost all of your code has been moved to the client side, and there's no log file for developers to go investigate. The errors are just logged to the console, and then nobody can use them because 99% of your users aren't going to have an error console open, and the developers aren't going to be able to see any of the errors because they're on the client side. So the solution to this is to catch these JavaScript errors, either using a try-catch block or using the window.onError event handler, and sending over AJAX the errors back to the server, and then you can store these errors in a log file as you're used to, or you can store them in a database. And in fact, this is such a prevalent problem in single-page web app development that there's many third-party services that have become software as a services set up exactly to solve this problem. And they'll have lots of charts and graphs and reports that you're probably not going to implement. So I'd encourage checking them out. So as promised, the 3 keys to developing a far more engaging experience to keep users around for far longer are to move the logic and data to the client, load only the changes on the page that happen, and plan for the challenges. For the big challenges that the frameworks won't or don't handle for you most of the time are the broken back button, which you can handle through making the URL your API, search engine optimization complications, which are fixed through the escaped fragment, missing analytics, which you fix through putting analytics calls into your client-side router, and a lack of error tracking, which you fix by catching the errors and sending them onto third-party applications or onto your server for tracking yourself. All right, well, I want to leave you with this. When you go away, remember that you've got about 100 milliseconds in your application to respond to keep the users engaged, fully engaged into your application. You've got a second before they start to lose interest and their mind wanders off. And don't let your applications get to 10 seconds long where users are just going to lose interest and go away. Thank you.